Welcome to Lesson 1. I'm Mr. Swart and I'll be taking you through this lesson. First off, we're going to be doing an overview. We're going to be discussing some terms and definitions. First off, a scale. This is the accurate physical scale of an object as it will be represented in the real world. It will have physical dimensions. Bring me to the next one. A dimension is an object as a measurement scale. So millimeters, it's 10 millimeters or 10 centimeters or 1 meter. These are all different dimensions of an object, and it's generally divided into length, width, and height. Proportional relationships of objects. This relates to how they appear on screen. If you have one object next to another one, or you're trying to gauge the size of an object you don't have the dimensions or real world scale for, you would use this method to go ahead and gauge the appropriate size. Finally, we will also be talking about deformations. This is what happens in the absence of good mathematics. It's when an object is scaled up without taking its dimension into consideration and then trying to have it perform some action or some modification which does not have good end results. We will also be exploring some tools. Just really quickly, these will all be in separate videos. You will see the videos listed next to the name of each segment. First off, the scale tool itself. Then we'll be doing scale settings, relevant settings we need to do before we start our projects. We'll also be talking about proportional scale as an observational skill. And then finally, we'll be using the X-form modifier, showing you how to correct any deformations that may occur. So first off, I just want to continue this conversation a little bit further. Why is accurate scale? Why accurate scale is so important in 3ds Max? So to put it frankly, in the simplest terms, it is about the mathematics. The mathematics within this program is very seldomly used by the artist himself to create the artwork or final rendering or output. However, it is very much dependent on these accurate scales or dimensions for things such as simulation, like cloth simulation, cloth draping over an object. The thickness of the cloth needs to be accurate. For example, the object it collides with needs to be a real world scale, or the cloth simulation itself will fail and it will just create the results that are undesirable. So dealing with scale directly, this forms part of video 1.1. The scale tool, the object button is indicated on screen there. The top one is the one you will most likely see, and that is currently set to uniform scale. However, this is the active scale mode, whichever one of the three is active. Underneath that button, if you hold the left mouse button in on that button, you will find uniform scale mode. You will also find the non-linear scale mode, and finally you will also have the squash and stretch scale mode. Furthermore, if you right-click on that button, you will also have access to the scale transform typing. So what happens when one scales an object with a scale tool? Quite often, artists would create an object, be it a box or a sphere or a tube or a cylinder, and then physically scale this object using the scale tool to represent something else on a back reference image or something like that. And in itself, there's nothing wrong with this process. However, one must take into consideration what's going to happen with that object eventually. If it's going to be part of any texturing, it's going to be part of any simulations or deformations that you want it to happen, like you want to apply a bend modifier, you want to apply some other form of tool to it, modifier tool to it, it may have undesirable results because it does not have at that stage accurate measurements. It is now something that was originally a few millimeters in width and height and length, which is now representing something that is indeed meters across or centimeters, and sometimes that has negative effects on objects, most likely. So at this stage I'm going to pause this video just to test whether Max works, and I'll be back shortly. Welcome, we return with video 1.1, just to show you guys quickly where the scale tool lives. It's up here, and as you can see, currently it's the active scale mode is set to select and scale in uniformly. If I left click, hold my mouse button in, you can see I open up a flyout, and then from the top down there's the settings as we discussed before: uniform scale, non-linear, and squash and stretch. Additionally, if you right click the button, you will see the transform type in appear, where you can enter in either X, Y, Z values for each dimension, or you can also do an offset, which is based on the object as a whole, a percentage of that object as a whole, or individually X, Y, Y, or Z. Okay, cool. This ends this video. We're back with the second part of this video, video 1.2. We're going to be setting up our project settings to have accurate measurements, and how we do that. First off, you need to go to Customize, and then you're going to go to where it says Unit Setup over here. Click on that button and you will see your dialog appear. First off, you have two sections to this. First at the top, the System Unit Setup, and then the Display Unit Setup. We are going to be working in a display unit scale of metric using millimeters. This is only relevant to the actual amounts you see, or the values you see in the little boxes here. You type in the values. We want this to also be measured or saved as a system unit scale. If you click on this button, 1 unit must represent not 1 inch, but 1 millimeter. At this stage, this is your settings complete. You can click OK on this button first. Make sure that's set to millimeters. You leave everything else as is, and you click on OK. You have to double check those settings every time you start a new file or when you are creating a new project. Generally, you need to check the brief of your client and what measurement scale they prefer, or just ask them and they will tell you. Okay, so this is video 1.3. In this one, we're going to be talking a little bit about proportional relationships of objects, why it's necessary to sometimes measure items like that, or gauge or interact with them in that way. And on your screen at the moment, you'll see a blueprint of a table of some kind. And you would often find things like this on architect's blueprints or other schematics, where it has the measurements for you and it's all nice and dandy. Easy to read, easy to use, but it completely lacks the actual the mood or the style or the theme that you want to represent in your final artwork. And although this is a great starting point, it's not often the end result that you are going to be using. Instead, you would go and find some reference images on a site like Pinterest or other sources and try to find something that more closely represents the style of table or furniture piece that you want to create. As on the screen at the moment, you'll see there is a dining table with 4 chairs, and it's very difficult based on this image alone, which is often the case. You will suddenly be able to find a blueprint for exactly this object or this type of table. Luckily, many of these manufacturers use standard sizes, standardized measurements to create these objects. For example, the chair from the floor to where the seat area is, that's generally between 450 to 500. A table like this, a dining table, is from the floor to the top of the table, is generally 800 to maybe 1 meter. Generally speaking, it's in the middle ranges between 800 and a meter. So by knowing these standard values, it's often easier to just use an image like this and just kind of like gauge what the scale is what it represents. If you would take this measurement, for example, the leg, the top of the table, and you kind of like guess how wide this is, I would say this table is about as wide as it is tall. So if this is 1 meter high, then this table will be about 1 to 1.1 meter across. You can also see in this picture that from this measurement or this measurement that the table length is about double that. So it's probably about 1 meter by 2 meters by 1 meter high, just to make the numbers a bit simpler. Everything else in this on the tabletop can also be gauged in the same way. You can use, if this measurement here is 1 meter, I would say that that limit measurement of that glass is approximately about a third of that. So it's just about this much. So that would be about 300, maybe 300 millimeters roughly. The bottle gets further from you, so you need to also gauge those type of things. But the idea about proportional relationships are essentially, if you have all of these things constructed and you put them in the same type of arrangement, they must represent the same type of scale that you see on the image right now. And that you can only do when you have multiple pieces. Okay, so how do we bring that back into max, that measurements? The simplest way, as we've spoken about in the first semester or the first term so far, is to create a calibration box, or an object that represents a lower version, a simpler version of that object. Let's quickly optimize this. So we've got a bright green box, and you can see under its parameters, we have a length, we have a width, and we have a height. So we don't really know those. We're just going to type in there, length is going to be 2 meters, width is going to be 1000, and height is going to be 1000 as well. And this should give you an accurate scale representation of that table in the scene. We can also name these things. Please remember to name your things as often as you can. I'm going to be zeroing this out. So I go to my move tool, right click these spinners at the bottom just to make sure everything is at 0 at the bottom there. I'm going to type in here, I like to use an abbreviation for calibration underscore table, for example. I can now create more boxes. Let's say do a chair. And I'm going to say if this box from the left view, from the front view at least, if this box is 1 meter at the back, this being the floor, this being the back of the chair, I want to have that back of that chair, the height, to be around 800. I want my width and my length to be similar because it's a square object from the top. If you look at the chair from the top, I'm going to make it 500 by about 500. I'll then move this in place where the other chairs were, just to give you an idea. Make a few copies. Just put perspective on, and then you should see some kind of, already starting some kind of representation, giving you an idea of what that image looks like. Now granted, I haven't looked at the image since I did this, so let's quickly see how accurate I am. Right, so I'm just dragging in my reference image again to see a representation of both of those. Open the other one again, and you can see there that clearly there is some errors already. However, this is a much faster way to start off and gauge that height. To be honest, by looking at the image again, I think the table itself and the chair's back top bit is similar. So if this one is 800, I'm going to make this table, set that table height also to 800. Maybe a little bit higher, 850 or so. So that more closely represents the reference image. So as you can see, this is a very, very quick way to accurately gauge measurements, kind of styles, before you go and commit yourself to any single model, and therefore run the problem of having different sizes and incorrect sizes and things looking oversized on one thing and oversized the other thing, the other object. So it's always a good idea to start with this process first, to make sure that both of these objects kind of like align in their most basic, simplest forms.